All right, we're going to talk about one more section within limits here in this section 2 about the numerical and graphical methods, and that is infinite limits. So here are our definitions right off the top. It says the limit as x approaches c of f of x is positive infinity if f of x increases without bound as x approaches c. Okay, so what we're saying is as we get very, very close to c, the limit is whatever x is getting really close to, right? Well, to say that x is getting really close to infinity means that f is getting really, really big, and it's getting infinitely large, and it just keeps increasing and increasing, increasing, in fact, with no bound. So if f is increasing without bound, that is to say y is shooting up off to infinity, then we can say that the limit is positive infinity. Similar definition here, the limit as x approaches c of f of x equals negative infinity if f of x decreases without bound as x approaches c. Okay? So if it's increasing without bound, we'd say the limit is positive infinity. If it's decreasing without bound, we'd say the limit is negative infinity. Okay? It's worth pointing out here that, strictly speaking, if the function is increasing without bound, then it's not heading toward a specific value. And we said by definition the limit is the value that you're getting infinitely close to. Well, infinity you can't get any closer to it no matter how far you go, right? So you can't actually get close to infinity. So in a strict sense, the limit does not exist. The limit is a specific number that you approach, and infinity is not a number that can be approached. It's not a number at all. So strictly speaking, the limit does not exist, but it's a little bit more meaningful, a little more precise for us to talk about the limit being positive and negative infinity so that we can describe the behavior of the function, right? And that's what this is saying here. Let's look at some examples and make sure we're clear on this. So let's look at all these limits graphically here. So I'm looking right here at the limit as x approaches 2 of x minus 2. Okay, and so what we see is, so here's our function, the red curve, and then we're approaching 2, and we can see that at 2 we have a vertical asymptote, right? There's our vertical asymptote at 2, and we're remembering all of our fun rules about asymptotes from the graphing functions chapter, but what we see is that from the left the function goes down, and from the right the function goes up. So in fact it's going in opposite directions from the left and the right, which means we need to consider these one-sided limits and say, what happens as x approaches 2 from the left of 1 over x minus 2? Well, as x approaches 2 from the left, we can see that the function is going to go down, and it's just going to keep going down. As you get closer and closer to 2, you're going to keep going down infinitely. So you're going to go down toward negative infinity, and we would say that the left-hand limit is negative infinity. Similarly, as x approaches 2 from the right of 1 over x minus 2, the limit is going to be, as you move toward 2 from the right, so come over here to the right and then come back toward 2, so approach 2 from the right, we see that we're going to go up infinitely, right? So we're going to head up toward positive infinity. So we can say that the left-hand limit as x approaches 2 from the left of 1 over x minus 2 is negative infinity, and the limit as x approaches 2 from the right of 1 over x minus 2 is positive infinity. These two are not equal to each other, so we said that, yeah, technically neither of these would both be DNEs, but this is a little more specific type of DNE. But since they're heading in opposite directions, we can talk about the limit as x approaches 2 and say, well, since it's heading in opposite directions as we go toward 2 from opposite sides, positive infinity and negative infinity aren't equal to each other, so we'd say the limit does not exist. So there's really three things to notice here. The left-hand limit is negative infinity, the right-hand limit is positive infinity, and the overall limit as x approaches 2 does not exist. Let's move on and look at another couple of functions here. Let's look at part B. So if we look at this one, we're looking at the limit as x approaches 0. So we want the limit as x approaches 0 of 1 over x squared. Well, let's think about left and right-hand limits here. So from the left, we can see that the function is going to go up shoot up toward positive infinity, so we'd say the left-hand limit is positive infinity. From the right, we can see that as we approach 0 from the right, the function is going to go up toward positive infinity. And since it's going toward positive infinity from both directions, we can actually go ahead and say then that the limit as x approaches 0 of 1 over x squared, since these two are equal, the limit of the function at x equals 0 is positive infinity. So again, we still want to think about those three pieces, but since the left and the right-hand limit function, or left and right-hand limits are equal in this case, we can say that the limit as x approaches 0 is positive infinity. We'll do one more here for the natural log function. We'll notice we're only asked for a right-hand limit here. So let's see what happens as x approaches 0 from the right. As x goes towards 0 from the right, as x is closing in on the origin, the y value is going to decrease infinitely without bound. And it's really, really looks like it gets on top of the y-axis. We know better. It doesn't ever actually get on top of the y-axis. It just gets infinitely close to it. So as x gets infinitely close to 0, the function value heads down toward negative infinity. So we can say the limit as x approaches 0 of the natural log of x equals negative infinity. We wouldn't talk about the limit as x approaches 0 because the function is not defined anywhere to the left of 0. So we won't talk about the left-hand limit at all, and we wouldn't talk about the limit as x approaches 0 because the function is not defined anywhere left of 0. Okay. So that's a discussion on infinite limits. They pretty much should always be taken in at one hit, or you should always consider them by one-sided limits. And then if they happen to be equal from opposite sides, you can talk about the whole limit or the limit as x approaches that particular value. Okay, so that's infinite limits, that's one-sided limits, that's graphical limits. So that's the end of section 2. So you have some more practice here, doing a little bit with graphical and infinite limits and one-sided limits. And that ends our discussion on graphical and numerical limits.